eet105, Chapter 7, Problem 28. It says for the ladder network, lunch shown in figure 7.91 below, determine R sub t. So first thing you want to do is start at this side. Start at the right-hand side. You can see that R6 plus R7 plus R8 is 4 plus 2 plus 1 is equal to 7 ohms. That's what they did here in the parentheses. And then they took R4 in parallel with it, and they called that R sub prime t, or t prime. So 2 times 7 over 2 plus 7 equals 1.56. So then the next step is they took R double prime t, which is going to be these four resistors, which is R prime t, added to R3 and R5 in parallel with R2. So they're kind of skipping a lot of steps here, but so I called R triple prime t these three together, okay? And there's a reason I did that. We'll get to. R3 plus R5 plus RT prime is this, which is R triple prime t, which is 4 plus 1 plus 1.56, which ends up being 6.56, and parallel with the 2 is 2 times 6.56 all over 2 plus 6.56, which is 1.53. Then R sub t is going to be RT double prime in series with R1. So you just add 4 to the 1.53 to get 5.53. Then to calculate Ri, which is the source voltage or current, you use Ohm's law. E equals IR, so I equals V divided by R. So it's 40 volts divided by the total resistance, which is 40 divided by 5.53 equals 7.23 amps. Then part C, find the power delivered to R7. What you're looking for is the current through R7. We could call it I7. So in order to get that current, you got to do the current divider twice. You take this current flowing through here, it divides right here. Then you take that current that you figured out what it was, we're going to call that I3, and divide it here. And we're concerned about this current going through that resistor right here to get the power. So I3, using the current divider one time, is going to be R2 times the source current coming into this node. And the reason why we used R2 is because, remember, one of the current divider formulas is when you have two resistors in parallel, if you consider this network here one resistor, which again I'm going to call it R triple prime T, we figured out that to be 6.56. So we're going to take I times R2 divided by R2 plus R triple prime T. And when you do the math, you get 1.69 amps. So then, doing the current divider again, you have these three resistors, which you can consider to be one resistor, be 4 plus 2 plus 1, which ends up equaling 7. That's in parallel with the 2. So again, you take your current coming through to this node, which is what we just calculated as 1.69 times R4 divided by R4 plus this equivalent resistance right here, which is 7. So then you calculate that to be 0.375 milliamps. And then the power through resistor, power being delivered to or dissipated by, in an ideal world, resistor 7 is going to be the current through R7 times its resistance. Current squared times its resistance, which is 0.375. It's amps. That's a typo. It should not be milliamps. Squared times 2 equals 0.281 watts.